formal proof of the chord theorem. Here there is a circle and we have AB as a chord. OX is the straight line which is coming from the center of the circle towards midpoint of the chord. And the data are given in the diagram. By using these data, we are going to show this angle as a perpendicular one. That's what we need to show. The theorem says if these two are like this, that would be perpendicular. Now we are going to prove that with other relationship. So this is the detail we have. With the enough details, we are going to prove the angular relationship. For that, you should draw some construction line here. Okay, so here I joined AO and OB by using dash lines. So first, the construction. You should write the construction. What are the construction we did to prove the theorem? Construction was joining OA, OB. For further calculation only, we joined OA and OB by dashed line. Now we can move to the proof part. What I'm going to do is, I'm going to prove these two triangles are congruent. If these two triangles are congruent, just carefully listen to my words. If these two are congruent, we can write the remaining corresponding elements are also equal. In that case, look at this. These two angles are lying on a straight line. If I consider this triangle is congruent with this triangle, these two angles should be same. Both should be same. If it is 70, it should be also 70. If it is 90, it should be also 90. But we know one more theorem that in a straight line, the adjacent angle sum is 180. Accordingly, if these two should be same, the 180, it should be divided into two equal parts. It should be 90, it should be 90. Likewise only we are going to prove. Okay, first let's prove. Thereafter, you can understand what we proved from the relationship. In triangle OAX and triangle OBX. In triangle OAX and OBX, first I can write OA equals to OB because those are radii of same circle. Radii of same circle. Radii is not the correct answer. Radii of same circle. If you have two separate circles, their radii are different. So you should write radii of the same circle. Next, this is a circle. You can write it as a circle. Next one, AX equals to XB. AX equals to XB. How these two are same? Because in the data they were given. If X is the midpoint, the total AB would be bisected by the X. AB, AX equals to XB. Why? What is the reason? Because X is bisecting X is the midpoint. That is enough. If X is the midpoint, that will bisect. No, X is the midpoint. Thirdly, one more. Here we didn't have any clues about the angular relationship. So we proved this and these are same. This one and this one are same. And this one you can see between these two triangles OX, that is the common side which belongs to both of these triangles. Common side. So now we proved all three sides of this triangle is equals to all three sides of this triangle. It means therefore triangle OAX congruent with triangle OBX. under the condition of SSS. All three sides are same with each other. Now, try to understand. I'll repeat once more. If these two triangles are congruent, all the corresponding elements should be same. This one should be same for this one. Hypotenuse sorry, should be same. This one is same to this. We just proved everything related to lengths. Now about to deal with angles. Its identical angle would be this one. You can see. So if these two are congruent, this should be same with this one. This should be same with this one. Likewise, this should be same with this one. Since these two angles are aligned in a straight line, summation of both of these angles would be 180. No? Sum of these two would be 180. So therefore we can offer here 90, here 90. We will prove that with proper detail. Okay. In congruent triangles, remaining corresponding elements are same. So likewise, we can write OXA that should be equals to, this angle should be equals to OXB. But it doesn't say this is perpendicular, but these two are adjacent angles on a straight line. So summation of these two angles would be equals to 180. But OXA plus OXB, both, when we add both, that would be equals to 180. From that, we can write instead of OXA, I will write OXB here. Okay, I'm going to substitute OXA with OXB. So OXB plus another OXB, that is equals to 180. 2 times of OXB is 180. Finally, OXB, that is 90. 180 divided by 2. OXB, that is 90. OXB, this angle is 90. We just proved the Chord theorem is correct. How did we prove? First, we shown these two triangles are congruent. Thereafter, in congruent triangles, corresponding elements are same. That's how I just written a relationship as OXA equals to OXB. But since these two are adjacent angles on a straight line, you should know the reasons. Okay, you should know the reasons. Since these two are aligned on a straight line's adjacent angle relationship, summation 180. Thereafter, we got OXB as 90. That's all about this proof.